Determine the greatest common factor and least common multiple of 12 and 16. So we'll find both the greatest common factor, or GCF, and the least common multiple, or LCM, using the prime factors of 12 and 16, as well as this Venn diagram shown here. Let's begin by determining the prime factorization of 12 and 16. So 12 is equal to 4 times 3, 3 is prime, and 4 is equal to 2 times 2, both are prime. So the prime factorization of 12 is 2 times 2 times 3, or because we have two factors of 2, we can write this as 2 squared, or 2 to the second power, times 3. For 16, let's begin with 4 times 4, and 4 is equal to 2 times 2, and we know 2 is prime. So the prime factorization of 16 is 2 times 2 times 2 times 2, which using exponents can be expressed as 2 to the fourth. Now let's look at our Venn diagram. We want the set on the left, or this set here, to contain the prime factors of 12, and the set on the right to contain the prime factors of 16. In this overlapping region, or the intersection of these two sets, would contain the prime factors that are in both 12 and 16. So looking at the prime factors of 12 and 16, notice how they have two factors of 2 in common, which means two 2's would be in the intersection or the overlapping region of these two sets. So we'll put two 2's here, and by recognizing the prime factors that 12 and 16 have in common, we're determining the greatest common factor, where the greatest common factor, or GCF, is the greatest factor that divides the two numbers. So we can always find the greatest common factor by determining the prime factors the two numbers have in common, which would be again in the intersection of the two sets containing the prime factors. So the greatest common factor is 2 times 2, which equals 4. 4 is the greatest factor that divides both 12 and 16. And now let's complete the Venn diagram. The set on the left must contain all the prime factors of 12. Notice right now the set only contains two factors of 2. Looking back at the prime factors of 12, notice how the set is missing the factor of 3. But because this 3 is not a common prime factor with 16, it must go in this region here. 3 is a prime factor of 12, but not a prime factor of 16. Now looking at the set on the right, this set must contain all the prime factors of 16. Right now the set only contains two factors of 2, which means it's missing two additional factors of 2 here. So these two factors of 2 must be in this region here, the prime factors that are only in 16 and not already in. So from the completed diagram, we can now find the least common multiple. The least common multiple, or LCM, is the least number that is a multiple of two numbers. It's also the smallest number that is divisible by the two numbers. So if we were to combine all of these factors, or take the union of these two sets, this would give us the least common multiple. So the least common multiple is equal to 1 factor of 3 and 4 factors of 2, which we can write as 2 times 2 times 2 times 2 times 3 if we want, 2 to the fourth times 3. 2 to the fourth is equal to 16. 16 times 3 equals 48, so the LCM is equal to 48. 48 is the smallest or least number that is a multiple of both 12 and 16. It's also the smallest number that is divisible by both 12 and 16. If we have a number that contains all these factors, because it contains the prime factors of 12, it must be divisible by 12. And if it contains all the prime factors of 16, it must also be divisible by 16. Looking back at the prime factorization of 48, notice here are the prime factors of 12, which is why 48 is divisible by 12. And here are the prime factors of 16, which is the reason why 48 is divisible by 16. 48 is the smallest number that is divisible by both 16 and 12. I hope you found this helpful.